So we're 3-3 day 2. We expanded yesterday. We're going to condense today. I'm just going to go through 2 of the expanding just so we make sure we're on track and what we should be doing. So the first thing I have is log base 4 of 5x cubed y. First thing I would personally do when I wrote this down is put parentheses around this so I know what is all being taken the log of. It's a personal preference. So multiplication is what? Addition. So it's log base 4 of 5 Yep, but the 3 will go out front, right?
Yeah.
So it's going to be 3 log base 4. Ooh. I turned an O into a G. Log base 4 of x plus log base 4 of y. And we have no exponents because we expanded and moved this at the same time, right?
Yes.
Okay. So the next one, I have the natural log of 3x minus 5 to what power? What exponent is the square root?
2.
Half. Because this, when we do a root, it's the root over the power. So 1/2. Okay, so what do you want to do first? I'm going to subtract the numerator and the denominator, yes? Okay. What's going to happen with the 1/2
It's going to go front.
of what? Of 3x minus 5. So I have 1/2 natural log of 3x minus 5 minus natural log of 7. Now, do we have a rule for addition subtraction? No. So can you do anything with it?
No.
No. Now, what are the things you might mess up? Remember to look if you can reduce these, right? If this is log base 7 of 7, it'd be 1. You know, any of my rules applying, correct?
Yes.
Okay. So now we've expanded, we're going to condense. So we're going to go from here to there. So where did it come from is the question you're asking yourself. So condense each logarithm. So I have 1/2 log of x. Do you see why the parentheses come in handy? Plus 3 log of x plus 1. Okay, what do you want to do first?
Log x to 1/2.
Okay, so she's saying put this exponent back where it came from, right?
Yes.
So log of x to the 1/2.
Yeah. Plus log x plus 1.
So x plus 1 cubed, because again, putting that back. Now what?
And then log x to the 1/2 times x plus 1.
Yep. What is x to the 1/2 though? The what?
Isn't it x,
No,
Square root.
the square root. That's what I was trying to get you to say. So it's the square root of x times x plus 1 cubed.
If we were to just put x in 1/2, would you count that wrong?
Yes, because it has to go all the way back. And we don't, when we end problems, we don't have fractional or negative exponents, correct? Okay, what about the next one?
You'd put the 2 back.
The 2 back go there. I don't usually write that step. And then what's this? Division. So we have the natural log of x plus 2 quantity squared over x. Because that square is only on the x plus 2. Hopefully you're seeing the benefit of parentheses, because in the textbook they don't even put them. They just do this. And my brain goes, what are you taking the natural log of? Once I put these here, do I see it's the whole thing? Yes.
Is that ln or in?
ln, natural log.
I've been writing it as in.
You know, same, Blandon.
I'm just writing a line
It
and
looks
then
like
an
in.
Well, it should be an L, N. And some of my L's get a little, because I put my N and the computer doesn't keep up with me, and so it goes. On the calculator, they put a capital LN, but that's weird to me. But I guess you could do that if you're sloppy. Okay, so our last 2 examples. I have 1/3 of log base 2 of x plus log base 2 of x plus 1. What's different about this one?
That's
Brackets.
like saying
It's a bracket. So the 1/3 is on what?
all of it.
All of it. So the 1/3 is what root?
the cube root.
In the cube root? You got the problem written down. Am I going too fast?
Yeah.
So it's going to be the cube root. Oops. It's going to be the log base 2. Oh my gosh, I did it again. I make an O and then I make it a G. The log base 2 of the cube root of what?
X times x plus 1.
And you could even go as far as say log base 2 of the cube root of x squared plus x. Because that one's easy to do, right? You're not cubing out anything, or you're just distributing it in.
I'm still writing I.
Stop it. It's log. Okay, what about this next one?
Lots of division.
Lots of division. Well, you know what I do? Anytime I see 2 division in a row, I factor it out. Because that means that this... Can I write the natural log of 4 squared? Can I do that? Yes?
Why do you do that?
I mean, I put 4 squared. I said 4 squared and I wrote 4th. Can I write natural log of 4 squared? Is that okay? Okay. But I factored out a negative of these 2, so it's not going to be minus anymore. It's going to be what?
Positive.
Positive. So that means that all this up here... Oh, just a second. I'm going to erase that 3. That 3 had to have a natural log with it at some point, yes? So how did it disappear? How did the natural log... What rule was used? What rule, like, eliminates the log or the natural log?
If it's like
Yeah, like if it was the natural log of e to the what? 3rd, then that would just be 3, wouldn't it? So this was the natural log of e to the 3rd. So again, when we condense, we have to say, what was it? Because the inverse property tells me the natural log of e to the third is just 3, doesn't it? Yes? Okay. So this negative says I'm going to divide by these two things, what? What's the plus telling me?
Your times.
Times. And what's this plus tell me? Times. So I'm going to have the natural log of 7e cubed.
This is new.
Yes,
How did you get a plus in it?
because I factored a negative out of these two. That's why it's in parentheses now. Okay. So what I have is the natural log of 7e cubed minus the natural log of, well, 4 squared is 16, right? Times 2 to the 9th. 2 to the 5th is 32, isn't it? Because 2 to the 4th is 16, times 2 is 32. So 32 and 2 to the 4th is 16. So what does the minus say? Divide. So we have the natural log of 7e cubed. Isn't 16 squared 256? Yes?
Sure. Wait, how'd you get 2 16s in there?
Because 2 to the 9th, we split it up to 2 to the 5th and 2 to the 4th.
Oh.
We could have kept going. So like 2 to the 6th is 64. We could have kept multiplying it, but I'm pretty sure 16 squared is 256. So you guys should know this.
Yes, it is.
Okay, so times 32. Without a calculator, see if you guys can beat me correctly. I get 8,192.
Yeah.
8,192. Okay, so what are some things that happened here? When I condensed, I'm left with only how many natural logs? 1. Not 2. It isn't the natural log of this divided by the natural log of this. Okay? So that took a few steps, didn't it? I will expect you to be able to do, I don't know, 2 to the 6th is 64. You probably should be able to do 2 to the 7th, correct?
Yes.
Probably should be able to do 2 to the 8th. Probably 2 to the 10th, I would expect you to be able to figure out pretty quickly. That's fair, yes?
Yes.
3 to the 4th is what? What's 3 squared, guys?
27.
No, what's 3 squared? 9. What's 9 squared?
81.
81. So 3 to the 4th is 81. See how I'm doing those easier than taking 27 times, you know what I mean? So hopefully you're working on your squares and cubes because you'll need them. Questions? Yep, that's it. We're done.